This video is to help with the Unit 2, Part 1 and 2 warm-up. So the first question says to draw a picture of a function and then something that is not a function. So if we think about a function, that is for every input, there is one output. So we could draw a line like this. That would be a function. So if you wanted to check it, if you would do the vertical line test and draw a line through it, it needs to cross at one point. And again, we talked in class that that has to be anywhere that it has to cross at one point. So we could do a line like that. Another example of a function would be a horizontal line. That could be a function. So if you draw a line through that, it's going to cross at one time. Several people in class drew pictures of just individual points. And as long as those points are not lined up, so that if you draw a vertical line, it crosses one time. So very many different pictures of what you could do as a function. Same thing with not a function. In class, I talked about the circle being probably the most common one that is used to represent not being a function. If you draw a line through that circle, it's crossing at 2 points, so not a function. Somebody in class drew something like this. That wouldn't be a function. Again, if you want to go with just the points, if you have them lined up like so, that would not be a function. So to be a function, for every input, there is only one output. So problem 2, it says, what is the range? And range is your y values. So in class, we talked about drawing a line to the y-axis so you can see what those numbers are. And then you're making a list. And it does not have to be in order from smallest to largest. It could be random as long as you have those right numbers. Problem 3 is an example of figuring out which ones are functions. This is kind of like a multiple choice kind of question, but it could be more than one answer. So we take a look at letter A. We have a table. In class, we had said you're looking at your x's, and if all of those x numbers are different, this is a function. So letter A works. Letter B, if you check out, again, just your x values, you will see 18, 18, and 18. Well, all of these 18s have different y values, not a function. So for every 18, there needs to be one y value. You can't have 3 different y's. Letter C, because of this right here, that 6 is split and going 2 different directions, this is not a function. So one arrow coming from that left side. And then the last one, which is very similar to what we did in the first problem, if you drew the points, if we check each of those points is only being crossed one time. So D would also be a function. So a function, for every input, there is only one output. So for every X, there's only one Y value. All right, turning the page to problem 4, we are looking for domain. Domain is X, so we are just looking at our X's and making a list. You could do 2, 7, 7, or you could just do 2, 7 and just leave it like that. So you don't have to include all of the 7s because if it's listed once, it's already counted. All right, problem 5 and 6, we are going to find the slope of the line when we're given the line with the points. So it is easiest to pick the 2 closest points together. And we want to see, all right, how much are we going down and over? So we're going down 1 block and we're going over 3. So our slope for problem 5 is -1 over 3. We're going down 1 over 3. And you could check down 1 over 3. Okay. Problem 6, we are going to take a look at how much we're going up and over. So we're going to go up 1 over 2. And again, you can check up 1 over 2, up 1 over 2. So our slope is going to be 1 over 2. So again, looking to see how much you're going up and how much you're going over. And then the final two problems are using our slope equation. So we know this is x, this is y, this is x, this is y. So we have our equation that says y minus y over x minus x. So if we take a look at that, we're going to do negative 25 minus 5 on the top, and then 7 minus 72 on the bottom. So we're taking x minus x. If we put that all together, we get negative 30 over negative 65. And I gotta just check 30 over 65. If we simplify that, will give us positive 6 over 13. So it's always a great idea to leave your slope as a fraction. If you got a decimal, it was like 0.46, but it's always a better idea to leave it as the fraction. And again, you can plug this right into your calculator. And then the final problem, same thing. We have xy, xy. So we're going to take 4 minus 6 in the top, because those are your y's, and then x minus x on the bottom, 9 minus 6. So that leaves us with negative 2 over 3. And that's it.